I'm Rachel from DCPE and my project is low-cost machine learning with object classification. What my project focuses on is making a self-sorting recycling bin with the aim to reduce the contamination problem and increase recycling rates. I am continuing this project from the previous intern, and my task was to improve the machine prototype that she had made in terms of design and functionality. The first problem is that there is a small population of bottle types, and the machine can only recognize a few types of bottles within the same category. Previously, we were using a strip board, so there were many messy wiring, and if there was a point of failure, it would be hard to troubleshoot. The third problem is that there is no control environment, and this can affect the prediction results. There was inconsistent lighting and different backgrounds used when training the dataset and when testing it in the machine. When it is too bright or too dim, it can affect the image quality, and all these can affect the training and testing process and accuracy of recognizing the bottles. Fourthly, unstable machine parts. Some parts of the machine are loose or unstable, such as the platform and the camera mount.
This is H-Impulse, a machine learning software. It is where I collect my data and train my models. So here you can see my training dataset. I split my whole dataset into training and test sets, so 80% and 20%. Alright, so after I've collected all this data, I can go ahead and create my impulse. This is where I pre-process my data. In my image data here, I can resize the image, and then I can go ahead and choose the type of machine learning algorithm that I want to use. I use transfer learning as it is suitable for small datasets, and new datasets can be retrained much quicker compared to other machine learning algorithms. Alright, so here are the parameters. I choose grayscale because my microcontroller, Portenda H7, can only recognize images in grayscale, right? So this is the neural network settings. I can determine how many training cycles I want and the learning rate, and then data augmentation to produce more versions of the image. This is the schematic diagram I've created using the Eagle software. And then after I created the schematic, I organized the PCB board. So here it is.
Thirdly, to create a control environment, I cover up the machine and I experimented with different lighting positions to ensure the light is not too bright or dim.
Fusion 360 to redesign the camera stand and the servo mount. I use AWS to create a server and a database. I installed the web server in my instance, and after that I configured some of the files inside of it, like the PHP script, and then modifying parts of the configuration files like this. This is my SQL workbench where I create the table in the database by declaring the variables here, and then using these two commands to show any entries made if there is a bottle detected. I modified some of the Arduino code that the previous intern made by adding in this to have the machine face the user when it first starts. And then I also included this while loop so that the door closes when the user presses the button again.
Overall, my internship experience has been fulfilling. I had the opportunity to explore and use various types of softwares and applications, as well as learning more about machine learning. Although there were many challenges, it was a good experience for me as I had learned many things during my internship.